Well, welcome to the community call number 70. I'm your host, Mark Fussell, a maintainer on the Dapr repo, and it's great to have you all here today. We have a pretty interesting agenda where we're going to dive in and do a little update about the upcoming release for the version 1.9 that will be coming out. And in that, both Jeroen and Alessandro will dive into a couple of features that we will highlight inside this release. And then I'm going to spend some time talking about the release process. We have a release process with Dapr today about how we build and run releases. And I'm going to run through that and just kind of add some clarity to it all, because we have an interesting proposal where how you can get involved more with what's happening in the release and understand how you can contribute more to this. And then, as always, we'll finish up and have an open discussion and time for questions. So feel free to ask questions as we go. We'll use it for that time at the end. Any question is open to discussion, so please post them in the chat window. So with that, let me dive into first, just mentioning that in 3 weeks' time, or less than 3 weeks, DapRCon is happening. It'll be happening on Tuesday, the 25th of October. If you can join us in person, we'd love to see you there. It's an all-day event. You can see the agenda on the right here. If not, you can certainly join us virtually. It's an amazing lineup of speakers from a diverse set of companies and organizations and individuals, so please join us. This is the last time we'll have a reminder on the community call before that event happens, so we're pretty excited by it all. If you don't have a chance to attend it all the calls will be recorded and posted up onto the CNCF YouTube channel for viewing afterwards, but that usually takes a couple of weeks. And so as best you can, attend it virtually or at best in person. So let me dive into a little update about the 1.9 release. So the 1.9 release is in process at this point in time, and amazingly, you can go out right now and try it out. We released release candidate number RC3 a few days ago, and that contains all of the latest updates to features. You can install it with the latest runtime, or the runtime for the release, and go and try it out. We'd love to have your feedback. It's a very important time to try out a particular release so that we can ensure that it fits with your particular scenarios, make sure there's no issues, breaking changes inside it all. And if you do have any questions on this, post it onto the general channel and we'll jump onto it. So that's something that we'd love to have your involvement and engagement with. Highlighting a few of the things in the release, of course, the detailed release notes will come out with the actual release itself, but I thought I'd highlight a couple of things with it. We're looking at it through the components lens. One of the main things that's happened in this release is many components. In fact, these 9 components have moved to a stable. And if you're familiar with the process inside components, they go through the life cycle of alpha, beta, and stable. Stable is where they have both conformance tests and certification tests for their validity, and that's the point at which the component can be most guaranteed used to be in production. So these components now are moved into effectively production status. You can use them in production. It's not that you can't use any of the components in production, but the validity and validation tests around this, or the certification tests, make sure that these are backed up by conformance tests that make sure that they run in a stable environment. And then along with that, we have 3 new components, 2 for the configuration stores, 1 from Azure, 1 from Postgres configuration store, and then Alibaba added a simple cloud log storage output binding into their collection of other existing Alibaba components. So go and check out some of these new components with the release. In terms of features, I highlighted these 5 features. Interestingly, we've covered many of these features already in previous community calls. So for example, pluggable components that Jeroen will give a little update about today was also featured in a previous community call. We'll dive into that more today. We also covered the open telemetry protocol used inside tracing. This is pretty important because now you can use open telemetry protocol along with the Zipkin protocol for your trace events. We covered multi-pub-sub tenancy in call number 68. And then you'll see that there's a Windows MSI installer coming out. And another feature we'll dive into on this call is the application health check and how you can use that. So with that, let us switch over and talk about the pluggable components feature update. So Jeroen.
Yeah, thanks, Mark. Let me share my screen. Can you see it?
Yes.
All right. Cool. So let's talk about an update we did to Pluggable components. That's going to be pretty short. I'd like to start off with a couple of thank yous to Marcus and John, who've been driving the design and implementation of this feature. You've been great and awesome. And thank you for myself and the other Dapr maintainers. So this is what Dapr looks like today. In a pretty high-level overview, you have the Dapr binary and all of the components that you're using, whatever the API is, whether or not you're talking to Dapr via HTTP or gRPC, eventually, for most of these APIs, you'll have a component backing them up, or a component commit states or a pub sub, and all of these components are compiled into the Dapr binary at runtime. Meaning, if you have your own private system, for example, an on-premises system or a legacy system, or just a component that you can't actually contribute upstream, you need to basically do a bunch of steps and go through a pretty complicated journey in order to add your custom component. So all of the components must be written in Go, and they must be compiled to the Dapr binary. And so if you were to add a private component before 1.9, you would have needed to fork Dapr, the main Dapr project, then fork components contrib, which is where we keep our components. You'd need to write your custom component in Go, and then build a Dapr sidecar and compile it with your new custom component, referencing your own implementation of the components contrib repository that you have. And then you'd need to configure your environment with a custom image and process for the version of the Dapr binary that you built. This all greatly reduces in complexity with 1.9, where the steps are basically to write a custom component in any language. That's actually not that true. There's like 8 supported languages today, so not any language. We will be posting in the docs exactly which languages are supported, but the major ones are there. And then you basically take that binary and you drop it into the local file system. And it communicates with Dapr over gRPC, and there is a discovery mechanism where Dapr discovers the pluggable component via a well-known Unix domain socket. And so the change that we did was say bye-bye to the pluggable component CRD. So if you've been following previous calls, or if you've been following the GitHub issue, you might have remembered that we had this new CRD that came along called pluggable component CRD. And if there's one thing that really represents complexity in the Kubernetes landscapes, it's CRDs. There's a project with over 30, 40, sometimes 50 CRDs. It's complicated from a user experience perspective, and from a code perspective, for maintainers, it's a lot of maintenance, keeping these CRDs, in check and testing them. And so we revised the design, and we basically removed the pluggable component CRD. And now you basically define a component just like you would have with a component that's actually compiled into the Dapr binary. So this is an example of some custom database that I have, state.mydb with metadata that can be whatever. This is specific on your own implementation, and all of the fields that apply to regular components in the schema for the component CRD also apply to pluggable components. So this is a revised user experience. You can just reuse the existing component CRDs. Yeah, and that's it. So unless there are any questions, I'm going to stop sharing.
No, that's it's going to be a great feature for everyone to be able to take advantage of now, so that they can now build components in non-Go and do private components themselves. Yes. Excellent.
Yeah.
All right.
But this.
Any questions? All right. Well, with that, I will share my screen again, and we will now move on to another feature inside of 1.9 release, where we'll talk about the application health check and what it provides you. So, Alessandro.
Yes. Hi. Let me share my screen. Please let me know when you can see it.
Yeah, we can see it.
Okay, perfect. So this new feature is something that we have developed for Dapr 1.9, and at a very high level is a way for Dapr to monitor the health of your application and to react to changes in the health. So to explain why we need that, let me show you a demo of what Dapr looks like today. So I have here my terminal, and I'm going to run, I'm sorry, copy paste error. I'm going to run an application that uses Dapr. And this is just a regular application that is configured with a binding that sends a message every second. Why is my terminal not copy pasting? Okay, so you can see here the application, excuse me, is receiving a message every second from Dapr, and this is through a binding. It's actually the Chrome binding. Now, things happen, and sometimes applications do crash. You might have a situation where your application either crashes or becomes unresponsive, and Dapr-D, the runtime, does not crash. So what happens in that case? Well, let's just kill the application, and you can see that Dapr is normally in 1.8, but also in 1.9 without any change. Dapr continues to send messages through input bindings, pub/sub, or service invocation. And you can see here that the binding is still sending a message every second. Now, this is a Chrome binding, and I don't care about the messages, but imagine this was a pub/sub component or a binding delivering messages that your application has to process. Dapr would still try to deliver them, even though the application is down, and the messages are not processed, and the application is not going to be able to process the messages. So at the very least, this is not polite, because Dapr is pulling messages from a queue, but it's not, it knows that, or it should know that they cannot be processed. So how can we deal with this? Well, in Dapr 1.9, we are adding a new feature called the app health check. So the first thing that you need to do, and this is just for 1.9, right now the feature is in preview. So you need to change your Dapr config file, which whatever the file is normally in a development environment is .dapr/config.yaml, and you need to enable the app health check feature, because this is a preview flag. In the future, this will not be necessary, but at least for 1.9, maybe 1.10, this will be necessary. So after you've done that, we are going to change our application slightly and add a health check. You can do that with both gRPC or HTTP. In the case of HTTP, what we need to do is create a new endpoint, which in this case I call the health_z. And in here, it just returns a 200 or a 2XX, for example, 201, 204, any 2XX status codes work if everything is fine, or it returns any 400 or 500 status codes if there is an error. You can also use a gRPC if your app channel uses gRPC. In this case, if you're using the latest version of the Dapr Go SDK, there is a new method called add health check handler. This works also for HTTP if you're using HTTP as through the SDK. This is only used if you're using HTTP. In this case, I'm using gRPC, so it's ignored. And then here, same thing. If it returns nil, it means that the app is healthy. If it returns any error, it means that the application is not in a healthy state. In this case, the application can also do some internal health checks. For example, you could say that we respond with a OK status code, not only if the application is running, so if the application can actually respond to the health probes, but also if we could do some checks. For example, we could check if we can connect to a database, or if a file is present, or whatever your application needs to do to be successful. In this case, we have implemented something that it's pretty simple, but it just executes this plan. So for every health check, the first one will respond OK. The first one has to be OK, otherwise Dapr does not think the application is ready. And then we will fail for 4 times, and then we will respond with success. And then after that, it's random. So now that we have the application done, let's also look at how we enable the health checks. There are a few new flags in the Dapr-D command line, and also equivalent annotations for Kubernetes. The first thing you need to do is to enable the health checks by setting enable app health check or the equivalent annotation. By default, they're disabled, and that just set the flag or set it to with a value of true. If you're using HTTP, you need to also set the path. The default is /health. The channel use is the same channel that you normally use, the app protocol flag or annotation. And then you can set an interval, which means how often the Dapr should probe the application to check if it's healthy. In this case, the default is 5 seconds. So Dapr will send the request every 5 seconds. There is a timeout in milliseconds. So Dapr will send the request and wait, in this case, 500 milliseconds or half a second before just giving up and assuming the application is down. And there is a threshold. So by default, Dapr will send a request. If it gets a success, all good. If it gets a failure, it will not consider application failed right away because maybe the application is just busy and couldn't respond on time. So it will just try again and try a third time. If 3 times in a row the application fails, then it's considered unhealthy. And this is configurable with this threshold as well. You could set it to 1, and in that case, every failure would make the application be considered unhealthy. So I think enough talking. Let's just show what this looks like. And I'm going back here, and I'm going to start my application again. So starting Dapr, but this time I am setting these 3 flags. I'm setting enable health check to enable the feature and saying that I want to do that every 5 seconds. In this case, I'm using gRPC, as you can see here, app protocol. So actually this flag health check path is ignored, but I'm adding it here anyways. And the other values are default. So Dapr will do the check every 5 seconds, will give the application half a second or 500 milliseconds to respond. And after 3 failed attempts, it will consider the app as failed. So let me start Dapr. And then on the other terminal, I'm going to start my application. Same command as before, nothing has changed. Now you will see that the application is considered healthy. You see app enter healthy status. Dapr starts delivering messages. And the first health check is successful. Then it starts responding with a failure. 5 seconds, 5 more seconds. This is the second failed check. And the third one. And bam, you see that Dapr sees the application enter unhealthy state. And it stopped the binding. So the binding is not delivering the messages. Then it tries again. And then if you remember the plan, we said fail 4 times. So the 5th time is successful. And you see the application is back up and running, and Dapr starts sending messages again. And right now the application is doing randomly successes and failures. Let's see what the next one is success. So it keeps running. And if the application crashes or becomes unresponsive, Dapr continues to send the health checks that you can see here, and then keeps doing that. And the second one, and now the third one should happen in a moment. Here it is, the third failed check in a row, app enter unhealthy status, and Dapr stopped sending the messages. Dapr, however, keeps probing the application to see if it comes back online. And so let's bring it back online, and you will see the messages start again. So app health check applies to all the messages that that Dapr sends to your application. The most important ones are bindings and pub/sub because Dapr otherwise keeps receiving the messages. So if the application is unhealthy, Dapr just stops getting new messages from the component and stops delivering them. It also poses service invocation. So if another application invokes this app and this app is not in a healthy state, Dapr doesn't even try to invoke the app and short circuits responding to the caller right away. The application is unhealthy. And this is my demo for today. So let me know if you have any question. And I don't see the chat here. Oh, here it is.
Yeah, there's one question from Oliver. He says, "Oh, will a pod get removed from the service discovery if the application health check fails?"
So the app health checks are actually unrelated from Kubernetes. We try to make this in a way that is agnostic from the platform. You can use this on Kubernetes, but you can also use this on self-hosted, on Docker Compose, or whatever you use. Removed from server discovery? No, it's not removed from server discovery because the sidecar, or in this case, Dapr, if it's not in Kubernetes, Dapr is still running. So the other application can still talk to your Dapr, to your sidecar, but the sidecar does not deliver messages to the application. It just short circuits and says the application is down.
Yeah, I think if you have your own health checks, or actually if you're reusing the health check endpoint for Kubernetes health checks, or liveness probes really, then Kubernetes will essentially remove it if it fails. And then the next time Dapr will issue a service invocation call, we use DNS schema for gRPC, and that'll remove the actual endpoint for the service, obviously, from the list of local endpoints that Dapr caches. So yes, it should get removed if your application is signaling to Kubernetes that it's not healthy, the same way it's signaling to Dapr.
Yes, and as for resiliency, yes, so they will kick in, but the resiliency policies are unrelated from this. So a resiliency policy works that if the Dapr receives a message, let's say you have this binding here, the Dapr is sending a binding to the application fails to respond, then resiliency policy can kick in again and try redelivering this. when app health check comes into play is that it actually stops Dapr from reading the messages entirely. It's not like resiliency makes Dapr try to deliver them again. App health check stops the component entirely. Like if you're subscribed to a PubSub, you will unsubscribe. If you have a binding running, the binding will be closed. It operates at an earlier level.
Yes, but the combination of the two is interesting to have together, yes?
Yeah, oh, absolutely, absolutely. These are not alternative there. All of this is part of the work that we are doing on resiliency and observability, and all of these things should work together.
Yeah, so Dapr's resiliency policies on it delivering and retrying messages, and then Dapr calling back onto your app kind of provides an end-to-end resiliency between your app, between Dapr, and then the thing it talks to.
Mm-hmm.
Something I really like about this is that we support gRPC health checks right from the get-go, because it took Kubernetes, I think, 35 releases until they got to that support in Kubernetes 1.23. So it's really great to see that we have these gRPC health checks from the first iteration.
Yeah, and I think a comment from someone is like, you have quite a few of these health checks, both health probes on Dapr itself, both on the application and resiliency policies, and just making sure how they all play together and work together is kind of an important thing. So I think, that's something that we'll put clarity in the docs as we put the docs together for this, that you'll see come out in 1.9 release, and reading through those docs and giving us some feedback would be wonderful.
Okay, if there's no further question, back to you, Mark. Thank you.
All right, fantastic. So let me share my screen here again. So that was application health check. And this is all part of the v1.9 release. It's out there in the RC. Go and try it out. Go and try out the application health check that Alessandra just demoed. Go and try out the pluggable components and sort of the other features inside that and give us some feedback. So let me now move on to talk about a release cycle proposal. So what this is about is that Dapr is a release at the moment, and we go through a release cycle. And in fact, at this point in time, we're actually in the stabilization and the end game phase, and I'll go through what that talks about. But this part of this proposal is that we want to make it a goal and open for what the release is and how it works, and how is it that you can become part of it. So every OSS project, open source project, has a release cycle inside there. And if you go and look today, Kubernetes has a release cycle, and I posted a link to here to how it does its releases. They actually do 3 releases a year. And then other open source projects like Argo as well have a release cycle. And like all these other projects, so does Dapr. So the aim of just talking about this proposal today is we want to make the releases a lot more open so that everyone understands how it works and how you become more involved with this. And also just to bring some clarity to how this actually process works, and bring a clear set of steps between them all. So that's the goal of this proposal. I actually have a document written for this proposal that you can read offline itself. So I will post this in the chat window towards the end, and you can go and read that and give feedback on this. So let's talk about what Dapr releases are and when. So Dapr aims to release 4 times a year. If you look at last year, we actually released in January, April, July, and October. So going forward, you'll see a release per quarter or every 3 months, and you'll see a regular cadence of that happening. That's good, because what it does, it provides a balance between giving regular feature releases and bug fixes, giving end users time to adopt a particular release. You don't want it to be too fast yet too slow. And so you can have a schedule about where things come out, so you can roll those out into your operational in production. And also provides clarity on when the releases are happening, so that contributors can contribute to part of it and realize that maybe if they don't quite get it into an existing release, they know that there's another release coming. So basically it's a train of releases. All our current releases are sort of defined in our support policy. You can read the documentation here. And so when we look out, to past 1.9, you'll see that the goal for next year in 2023 is to have a release that will happen in the first quarter, second quarter, third quarter, and fourth quarter. Very similar to what we did this year in 2022. So effectively 110 you'll see sometime in the January, February timeframe, and then the 111 release will be sometime around April again. So this allows us to have a regular cadence around them all. So that, is when the releases will happen. So now let's kind of look, what constitutes a release. Well, a release really consists of a milestone. And what we should be stressed here is that Dapr is always in continuous development and in continuous integration testing. So although we sort of define this milestone, that doesn't preclude the fact that we are always fixing bugs, and we're always raising new issues, and we're always looking at how new feature proposals being raised. So it isn't just a single point in time thing, it's a continuous process. However, a release milestone is a time to reflect and bring some clarity to a certain set of features. So, we define a release milestone that goes through 3 phases. There's a feature definition phase, which will bubble up a certain set of features. There's an implementation phase, and there's a stabilization phase. And the milestone as a whole will last 13 weeks, broken down into 2 weeks, 9 weeks, and 2 weeks schedules inside all of this. So let's dive into each one of these phases then and sort of talk about what they encompass and what happens with inside them all. Actually, before we do that, there's another thing that we have to define, and that is the actual release team itself. So each time we have a release and we do a milestone, we actually pull together a release team. And that team is responsible for making sure that that release runs smoothly and effectively runs the process of a particular milestone. And the team changes between each milestone. So it's not the same person or even the same group of people that runs it. So before a milestone starts, we put together a release team. And this is something, we certainly want to get broader community engagement with, broader involvement with, and something that you can become part of. And there are really 5 roles inside the release team. One's the release lead, and he or she or they are involved with enforcing the process for the release and ensuring that everyone part of the community, the contributors, the community itself understands the status of the release, what's happening, and basically is the coordinator across the entire milestone. That release lead has shadows that people help them deliver on the release and basically play the same role, can either act as a backup and also help distribute the work around. Then there are 2 roles around the test leads for long haul performance and for long haul. And these are just specialized roles where, as part of the ongoing testing processes for integration testing, we have long haul tests and performance tests inside Dapr. And it's good to have dedicated people watch those tests so that we can make sure that throughout the milestone, as contributions happen, perf doesn't have a sudden regression and long haul doesn't have a regression, so that we're not scrambling in the stabilization phase at the end to find out issues halfway through. So this is part of the ongoing process for those. So those are sort of fairly dedicated roles, and of course they have particular details about how they work, and we can talk about those and how to become one of those. And then finally, in the stabilization phase, there's a release manager. That's someone who actually creates the builds, releases the RCs, does the branching at the end, and basically is responsible for cutting out the final RCs and the final build and testing and releasing branches around these. So this release team is defined in advance, and as part of before a milestone begins, and each one has sort of particular roles within inside there. So once you've defined a release team, we go through a set of phases, and the first one is this feature definition phase. And as I mentioned, this isn't really supposed to be like a single point in time, but it's a time where a certain set of issues bubble up targeting a release. And these are ones that are, particularly important to the community, or, certainly where a contributor can dedicate their time and they say, I'm able to put my time into this. It shouldn't detract from the fact that maintainers are still entirely responsible for triaging in issues into the milestone. So maintainers is still the core of the project to make sure that they understand what's happening in their respective repos and help prioritize these issues and bubble them up into this feature definition phase. And during this time, one of the things that we really want to do is make this feature definition phase a lot more open in terms of discussion. And that's where we're proposing on having a Discord channel called Proposals and Issues Discussion as part of this, that enables us to post on their particular features that are going to be in a particular milestone, have a chance to talk about proposals and use them as an open forum. Of course, Discord is one place. Part of the feature definition phase is we're also going to have some open virtual meetings, 1 per week, so you can actually do in-person conversations because those are sometimes easier to clarify particular topics. And, the particular features we'll have inside that milestone will have a chance for the contributors to talk about, why they see them important and what they intend to kind of deliver inside that milestone. So this feature definition phase completes by having a set of feature proposals, also a set of sort of significant other design changes that may be happening as part of the release that are sort of non-direct features themselves. And there are a set of triaged issues that are done by the maintainers into each one of the repo milestones inside each repo. And so this is basically setting the stage. It's never a perfect thing. It's kind of a good enough thing about what we can get done in this milestone. And of course, there's always sometimes, particular features that won't necessarily get delivered inside that, but this is a goal for that particular milestone. You then enter the feature implementation and bug fixing phase, and this is sort of the meat of the milestone, as it were. This is where we actually write the code, do the contribution, write the test cases, make sure that the whole feature goes through its life cycle, and gets delivered as part of that. And we should recognize at this point that sometimes when you start a feature, it might be a multi-milestone feature. So you might not even finish it in this milestone. You just have the objective to start it. In fact, many larger features, do span multiple milestones. Pluggable components is a good example of that. It started several milestones ago, and it's only now being delivered in the 1.9 milestone, for example. And inside this phase, maintainers and approvers still continuously do triages on their repos. I want to emphasize it's maintainers who drive, the decision-making processes within inside this whole release cycle. They are ones who are responsible for making sure that there's a continuous triaging of issues inside there. But each week, the release lead holds a weekly meeting on what's happening inside the feature implementation phase, where we look at issues within inside the status of the particular features that are being delivered, get a status on them from the actual contributors themselves, and then look at sort of the perf and long haul tests, and also generally look at the risks inside the milestone as a whole. So particularly as you get towards the end of the milestone, there may be some features that won't get delivered, and then at that point you want to de-risk the project and move it to the next milestone. So that discussion happens there, maybe even slightly adjusting the milestone by a few days if needed, just so that particular critical fixes can get in. But then the phase completes effectively with a code freeze period. And that's when we're done with all the feature work and we enter into critical bug fixing stage only as part of the code base and start building that out. So that means we enter then stabilization release, and that's exactly where we are right now with the 1.9 release. So we are sometimes called in the end game phase of the release, but the stabilization release is typically lasts a couple of weeks. And here now, the release manager runs through a task list that we built up, quite comprehensive task list. It contains over sort of 70 plus items, and you can go and look at issue number 5290 right now in the Dapr repo for the 1.9 task list that's being run through for the current release manager, and how that's being coordinated and allocated to different people. There are daily release meetings that happen that you can join and listen into, and effectively we manage and go through that task list. And then importantly, get the release candidates built out there into the broader community for people to try out and give feedback on. In fact, the reason that we're RC3 and about to go to RC4, because we found issues inside the current build already, and that requires fixes inside all of that. So that cycle of doing releases, RCs, pushing them out, getting the feedback, managing them all, looking at the bugs inside them all, and then going through his checklist is all of the stabilization and end game, supported by the release manager who does the actual builds themselves and pushes those out. And the release manager, the release lead, I should say, is sort of announcing the fact that we've got these RCs available on the Discord channel and making sure that the cycle of the stabilization phase completes. And of course, that all then culminates in the release of the build, the 1.9 release. In this particular case, that will happen in the next week or so. So that's the final 1.9.0 release. And then that sort of concludes at that point. And really, we've ended the milestone. And if you look at the doc I'll post, it then goes on and talks about hot fixes and patches as part of that. and things that kind of subsequently happen. But mostly this is the whole premise of this. So the point of talking through all of this is that we really want to make sure that this process is well defined. We're going to take this process and post it into the community repo so that there's clarity around it all. In many ways, as you saw, that there's one posted inside the Kubernetes repo about their lifecycle. And the reason for doing this is because we want to make sure that those meetings are publicly posted and available. You know exactly the stages that we're in. You know how to contribute and comment on feature proposals. You know how to comment on issues throughout the stabilization, throughout the feature implementation phase. And basically, even be able to join and become part of the release team itself. We would love people in the broader community to become any one of those roles I talked about in the the release team itself, anything from a shadow to release to actually running the release itself. And this way, we want to make sure that Dapr is a very open and collective project around all these things. So this is a proposal. This very much takes what we do today, but just adds some clarity around the actual steps within inside it all. And as a chance for effectively openness and understanding about what happens inside there. I think that's my last slide inside there. So at that point, I will just open it up for any questions. So if there are questions, please post them in the chat window.
I think there's a consensus. This was a really great walkthrough of the proposal, which is both a proposal and sort of like a description of what we do today. Yeah, I think this is really good. And yeah, I see you put the doc in there. So really encouraging everyone to take a look at the doc, put comments. If you have any desire to become a release team member, please contact maintainers. You can contact us on Discord. If you don't know our specific handles, and we'll put them in chat in a sec, just just write that you want to join the release team on whatever channel. We'll track that. Yeah, other than that, you can also open issues on the community repository, I imagine. And yeah, again, great proposal, Mark.
Yes, and we're going to be kind of putting this in place for 110 and getting this together. And so you'll see a lot more of this. You'll see this proposal in place. And particularly, as I say, the goal of this is very much so that the community can have involvement around this thing and make sure that you can actually have your voices heard inside here. Okay, so yes, please, I posted inside there the actual document of the details. This will be turned into a docs inside the community repo, and then these will actually get posted and put them out on sort of Discord channel later this week, ready for 1.10 when it starts, which will be in a week or a couple of weeks' time. Okay, with that, we move into the open discussion and question section. This is a time for now that you can just unmute, ask any questions, anything Matt comes here, anything about the 1.9 release, anything about what we talked about today, any particular feature that you would like to see, if you want to talk about a proposal, if you just have a implementation question, anything that you feel is important to you.
I would actually like to talk about an issue that was opened by Ollie, who I think is on this call.
Yes, I am.
Yeah, so actually, let me share my screen and we can talk about this. And we also have Arthur here, so it'd be good to get his feedback too. I'm going to share. Can you see my screen?
We can, yes.
All right, so
Yes.
you opened an issue today, which I think is interesting. So you're basically saying, hey, people today applied Dapr components via YAML, and the same way that we allow people to express subscriptions through code, you're basically like, hey, let's let developers express components through code. Is that a correct description of this proposal?
Yeah, that's pretty much it. Me and Italy Pale Ale, the Discord, the maintainer, we're having a chat in the state management channel on Discord about the possibility, and yeah, he said raise it as a GitHub issue and let's see if it goes anywhere.
Yeah, so I think this is interesting. The only thing I'm thinking is, maybe we change this to be generalized for all components. So you have like API, or actually we have the Dapr config API, right? I think for these purposes. So something like Dapr config whatever components, and then, instead of like specific endpoints for state stores and distributed locks and pub subs and secret stores, you'll just return a list of, JSON representations of the components.
Sure. Yeah. I mean, it achieves the same end goal.
Yep. And then how do you envision, secrets management for these components? Because like, let's say you have something like a password. So do you imagine a developer reaching out to the the secrets API for Dapr, grabbing hold of a secret or a token, and then putting it inside of the JSON that's being returned to Dapr?
Can you already reference secret store secrets from another YAML, from another component?
Yeah, that's actually doable also. Yeah, there's no reason why that shouldn't work. Yes.
Yeah, so
Yeah,
I'm not envisaging developers having access to the secrets directly and then embedding them in this. It would go through some reference.
All right.
So
Yeah,
the
that makes sense.
problem you will have there is, specifically with secrets, is that if you define them programmatically like this, you do need to have a secret store, an external secret store. And if you're not using, except if you're using the built-in Kubernetes secret store, then you have the chicken and egg problem, because you have to define the secret store component and you have to authenticate that. So you need to have the secrets for authenticating the secret store component defined somewhere. That might be, it's doable. It's just something that could be delicate. Perhaps secret stores should always be defined through a YAML.
Maybe
I think
inside the Dapr runtime, it would only load the secret store components first before it moves on to trying to load anything else through an endpoint. Maybe, I don't know.
Arthur?
Yeah, that makes sense. That makes sense. I think for secrets, the developer can optionally come up with a secret store here as well via this programmatic API. But then in case of, for example, Azure, it will work because you would have a managed identity on a managed environment. So there are scenarios that you would still be able to use secret store through this way, but I agree that most of the time you will want to declare the secret store outside as a YAML like we're doing today, and then you can see reference the secrets here after the fact. So you can load all the load all the CRDs first, and then call this API to load the additional components. So this way the secret store is guaranteed to always be there before it can be referenced here.
Yeah, on AWS and Azure, you're right. We do use like a managed identity or such concepts. I think returning a secret store here as part of the components that get returned to Dapr is also just going to be fine, because we have logic inside of Dapr to basically process all dependencies. So Dapr will look for secret stores first and then load them and then load the components that are dependent on them. So I think this plays quite well with how we do things today. Whether or not you load the secret stores prehand via YAML, or if you return them as part of the call here.
So
now one thing to keep in mind is today when you declare a component in the CRD, it has the name is globally unique, right? Or within the namespace at least. So in this way, do we want to make the name of the components bound only to the application, or do you also want that to be discoverable by other apps?
it will have to be bound to the application, because otherwise you need the application to start talking among themselves, and that is a slippery slope.
Correct. Yeah, this will be scoped to the application. This is as if, like what we're seeing here is as if you had a single component in a single namespace scope to the application that's using this with a, of course, unique name.
The only thing is that Oliver and I were talking about this on Discord. That's why I told him, like, please open an issue here. So the thing that I really like about this in Yaron, you sort of mentioned this before 10 minutes ago. CRDs are a pain in the bottom.
Yes, they are.
And just like the subscription CRD has an endpoint, the resiliency CRD will soon have an endpoint, or at least that is the plan, to my understanding. I think this makes sense to have an endpoint also for the component CRD. The biggest downside that I see here, that is the difference between subscriptions and components, is that when we allow this, we are removing one of the values of Dapr, which is that we allow separation of concerns, where there is, for example, the ops team that defines the components and developers that just use the components. So this is probably fine for 90% of customers, of users. Oliver said that their team doesn't seem to care about this, but perhaps it's something that should be like, there should be an option to disable this for users that do have the separation of concerns.
I would agree.
I think it's gonna be a part of the config CRD to say,
Mhm.
oh, enable application bound components.
Yes.
Yeah, definitely. Okay, I'm gonna stop sharing.
Thanks.
Okay. Fantastic. All right. Well, thank you for joining us on this call today, and we will see you at DapperCon 2022. I think we're most likely not to have the community call the week before that. I think the next community call that's going to be happening will be the first week in November. So this is the only community call we have this month in October, because you've got all the excitement of DapperCon coming, and we're going to be thrilled to have you there at that. So thank you for joining today, and see you later.
Thanks, everyone.
Thank you.
Thank you.